Good afternoon, everyone. Thanks for coming by. So my name is Alok. I'm a data science advocate at Google Cloud. What does that mean? It means that I'm a data scientist by trade, and I talk about how to use Google Cloud, for data science use cases. My background is in sports analytics. I was a founding member of the ESPN sports analytics team, worked there on projects like the total quarterback rating, football power index. Then I was a data scientist at Google. Now I work in Google Cloud data science with some sports projects, which we'll talk about. So what is Google Cloud? This is a question I asked myself when I joined a little bit over a year ago. And I think the simplest way I can put it is a combination of hardware and software tools that allow you to do things. So same infrastructure that internally Google uses to run Google Search, YouTube, and other successful products like that. You can imagine the scale of those products, right? This is the same infrastructure that is now available to other people, other companies and people to run their stuff on. From a data science perspective, what does it mean? We get insights from data faster, simply. So we'll show some examples of that. Sports. Google Cloud has many partnerships, and including some in sports, because sports is not only a really good place to kind of learn to use data and to demonstrate value, but also these sports enterprises have data problems, technologies, things they want to work on. So some of our partners, NCAA has been a multi-year partnership, working a lot with their basketball data to help both the basketball committees and also for some public-facing work, which I've been very involved in. Golden State Warriors, also again, some sports analytics pieces, but also a much bigger partnership around the Chase Center in San Francisco, sponsorship there. MIT Sports Lab, local partnership. They have a really good group led by Pekka Hosoi and Christina Chase, where students work on data-driven projects across, working with other organizations, and we help them with sort of cloud computing and sort of resources in that realm. Bottom right is the FA in England, another big partnership where we will help them with soccer, or as they would call it, football performance data. And we'll talk a little bit more about one example of that at the end here. And the latest partnership, which was just announced a couple days ago with Major League Baseball, really exciting. I'm not sure how many of you saw the panel earlier today, but went through some really cool use cases about how Major League Baseball and Google Cloud are going to work together to really bring forward the next generation of baseball. Okay, so in the title of this talk, I said the next level. You're here. Presumably, you've been involved in sports analytics or are aware of it. It's been going on for a while. This conference is in its 14th year. So what is the next level? And again, try to keep it simple here. I think you can talk about at least three things. One is doing things at scale. So what does that mean? We do what we do, but we do it bigger or we do it faster, right? We used to have game-by-game data. Now we have play-by-play data. Now we have player tracking data. How can we do bigger things and kind of keep without spending too much time on it? Making things easier, right? So I do the same thing that I do now, but I want to do it simpler because it's only one part of my job, and now I got to put it into a bigger workflow. Or maybe I have this level of technical skill, and to get all the way here is a little hard. How can I make it easier? And then the last category, which is maybe the more fun sort of aspirational things, is how can we do new things we never could do before? Is video data? I wouldn't have said so a few years ago, but now I think you're starting to see that it can be. Okay, so the first topic, doing things at scale. So there's multiple Google Cloud tools, right? And I'm not going to go through all of them because I would be here forever. But one that is really good for doing things at scale is BigQuery. So what is BigQuery? It's our enterprise data warehouse for analytics. Essentially, you can store as much data as you want here in relational database things and use SQL, which many of you will be familiar with if you're data analysts, to query tons of data, to do all sorts of things that you might not imagine doing on data sets of up to petabytes. And the other things that are kind of unique about it are we have the ability to incorporate streaming data and as well as to do machine learning right in the database. I should also mention the BI engine allows for dashboarding and stuff. This is a tool that I personally like a lot. I like to build my stuff in BigQuery and then display it in a dashboard without like building some fancy website or something. I just want something that's available. People can kind of filter, sort, look at some graphs. BI Engine makes it so that you can build that dashboard, and it's using BigQuery's backend to be really fast. If I have 1 million rows or something, no problem. All right, so this, that was the sort of generic BigQuery slide, but let's talk about a real problem. So we want to analyze player tracking data. Some of you will be familiar with the NBA player tracking data. Others will be a little less familiar. SportView initially, and then Second Spectrum has provided tracking data for the NBA 25 times a second, the ball and the players, the entire time during play, right? So we have this data for about 6 seasons, and the idea here is like, it's really hard to work with this data, right? But we can do 2 things. One step I'm going to thank my colleague Ramsey, who's sitting here for, which is that he used Dataflow to get it into BigQuery. I'm going to pick up there and say we have our player tracking data in BigQuery. But we still have a huge table. So if you look up at the top right, the table size is 1.6 terabytes, right? This is 7 seasons of data, 6 or 7 seasons, sorry. And it has 8,000 games roughly with about 900,000 rows per game. So that ends up being 7 billion rows. Usually you don't query 7 billion rows, you just don't. But in BigQuery you can. So to kind of demonstrate this, I wanted to ask a question that, isn't maybe the highest level research question, isn't gonna win the research papers competition here, but is something kind of along the lines of what you might think about asking with player tracking data. So, and I wanted to use the whole set. So which pair of players have been closest to each other when they're on the court together over all the data we have? So that's a question we're gonna ask. So how do we answer it? Some people may know SQL and some people don't. I'm a technical person, so we have SQL on the slide, right? So the idea here is, again, laid out here with the text. What we do is you look at every player on every frame who's on the court, and I calculate the distance between me and every other player, and we do that for all pairs of players. And then, again, we aggregate them, and we look at 2 metrics. One is the percent of time that they're within 5 feet of each other, right? So that's like pretty close, and we'll count that. And otherwise, we'll do an average of the separation. And we calculate the separation using this Euclidean distance formula that you might have learned in like geometry class. And then we filter by, make sure that it's a certain number of minutes, and then we'll sort on this, okay? So I don't, this is not, like, people come from different technical backgrounds. I don't think this is like by any means the most complicated query, but it takes a little bit of work. And the point isn't the SQL, the point is how fast it runs. So how fast do we think? We're gonna run this query over 6 to 7 years of data. How fast do you think this will run? Okay. So I think when I asked this in a different presentation, someone said hours. And I think I would have said hours, like a year ago. So I don't have the live demo, but it runs. So first we'll look at the actual basketball answer. So Andre Drummond and Hassan Whiteside are the 2 players who sharing the court for at least 250 minutes close to each other. You can see some pictures here. Kind of makes sense. They're both big guys. They don't really stretch the floor, and they probably guard each other on both ends. Actually, everyone in the top 10 has pairs of centers who are not really that, at least in the time of this data set, like moving around that much. So it makes sense. I didn't think about it this way, but it kind of comes out this way. So that's the interesting basketball nugget. Again, like you would want to do more here to make this a really interesting thing. But here's the part that was interesting to me. So this query ran about a minute, processed 672 gigabytes of data. Again, I would do this live. And if you want, I have my laptop and we'll do it. It's a little bit, this wasn't exactly the best setup for me to do it, but happy to show people that this does actually run in a minute. So that's amazing, right? So I asked a reasonably interesting question, and we got results in a minute. That's what we're talking about, doing things bigger, doing things faster. Okay, so the next thing, BigQuery ML. So BigQuery, again, database product, you're used to writing database queries, things you can execute, sort of like all sorts of join operations and filtering, not necessarily modeling, right? So one of the things that BigQuery's team has tried to work on is a way to operationalize machine learning within a database to make it easier for those who maybe don't have R or Python skills to do models. So this allows you to execute machine learning models without moving the data from BigQuery. You see the list of available models there. Again, it's not every single model. There's tons that aren't included. They're obviously working on others, but there's some of the ones that are like kind of fundamental. I come from a statistics background. I think you can do a lot with linear regression, logistic regression, and k-means. You don't necessarily need the most sophisticated deep neural nets. They have those too. But the key is, you'll see the little GIF that's running. Like, that's the code you need to fit this model. It's a couple lines of SQL, and it will automatically handle a bunch of these things. So learning rate, splitting into training and test, imputation, you can do regularization. Again, if these things are a little bit fuzzy to you, don't worry about it. The point being, you can do some fairly technical stuff without having to, again, move your like big data out of BigQuery and like writing a whole bunch of like custom code. So again, we'll look at an example. In this case, we'll stick with basketball. We'll go college basketball. So this is data from Genius Sports, who collects some play-by-play data for the NCAA over the last couple of years. We're talking about play-by-play, so not quite the size of what we just did with the player tracking data. It's only 780,000 field goal attempts. And we have the last 2 seasons, let's say, for men's basketball. And you can see an example from last year's national title game of the type of data we're looking at. We have some coordinates. We have some distance that we calculate from the shot distance, where it is, and whether the shot was made or not. So this is this is stuff we've had for a long time, shot chart type of data. But I just wanted to show like kind of a familiar question, like how can we answer it with BigQuery ML? So our questions in this case will be, who takes the highest value shots in the field and who makes the best shots? So there are more sophisticated ways of doing this, certainly in the NBA with the tracking data. But let's take a shot at this with college basketball using shot location data. All right. So again, we're going to show the code, hopefully not super intimidating, and we'll show some of the results. So top left is the create model statement. So I say create model, give me logistic regression, give me some regularization. Here are the features I want, and shot made is a label. So that's basically all I have to type in to create a model that will predict if a shot will go in or not based on the distance. And then when it runs, it will give you this output on the bottom left where it gives you some accuracy stuff and some metrics on log loss. This is a slightly better model than assuming the average of 43. It's more than slightly, I should say, 43% makes in the data set. And again, it's not intended to be the most sophisticated model. It's intended to basically give an idea if I control for shot distance and where on the court the shot came from, how hard is it to make. You'll see on the right, if I want to explore the weights of this model, sort of the coefficients in the traditional sense, you have this ability to basically select the weights, and it will give them to you in this sort of like table form. I pointed out a few that are important. Shot distance, the further it goes, less likely it is to go in. That's obvious. They have some area and distance are kind of correlated here. Again, this isn't a perfect like causal model, but at least gets the idea of controlling for these things. And I have another feature for if it's the final 3 seconds of the half, which means they're usually chucking it up. Okay. So my question was, who takes the best shots and then who makes those shots more than they should based on the quality, right? So that is another step beyond here. The key part here is, again, what I've highlighted. You can use a predict statement to then, again, apply the model you just created to this table and get predicted values for the shot. And then the next part is just some stuff I did to incorporate that one, the value of a 3-pointer and other things, right? So we can see here there's the 5 shots that we had looked at before. You get the probability of the shot made. Obviously, some shots are much harder than others based on distance. And then the expected value of a shot depends on if it's that probability as well as if it's a 2 or a 3. So we get a value, expected value of a shot, and then we'll compare it to if they actually made it or not. Okay, so now we're basically there. Now we just have to aggregate across all shots, kind of like the last thing, and filter. So we did a minimum of 300 field goals attempts in a season. This is college data, last 2 seasons, and we looked at the highest average expected shot value. So who takes the shots that are most likely to go in based on distance? Some familiar names here. John Morant, Zion, top 2 picks in the previous draft, Obi Toppin this year, Precious from Memphis, he's a good player. And then the next set is basically the highest average expected points versus expected. So given how hard of shots you take, how often do you convert them more or less? Again, you see Zion. So what this tells you is that Zion Williamson is good at putting the ball in the basket. And, you know, he does things like this. So this is not, I mean, this hopefully like at least is confirmatory that this makes some sense because we all know that Zion's good. But what else? Do we see another player who's on both of them and also takes good value shots and makes them? Obi Toppin. So this is a little, you know, if you're a college basketball fan, you know who this person is. But this is kind of interesting. Like he's maybe a player of the year in his conference, but I didn't know he was that good. And then I looked and like he's also capable of doing some awesome stuff. So again, not like the most super sophisticated analysis, but the type of question we can answer. And with minimal code, we're able to get to this type of result very fast. So let's move on to the last section here. So enabling new things. So we have a bunch of different tools at Google Cloud, AutoML and APIs, where auto machine learning, basically. So Google has a bunch of really smart people working on machine learning tools. And then eventually, they move into Google Cloud as customer-facing products. And the idea is not that you write the most complicated code to do your machine learning, but just that you can leverage it like sort of a application interface such that like you can just say, do the thing, and they'll do all the complicated stuff and return the result you want. So we're going to go through an example of that using cloud video intelligence. Okay, so we talked about the partnership with the FA. As a part of that, at the next conference in UK last November, there was a football peer demo. So football in the UK is what we call soccer. And over there, they were basically what was set up, and a bunch of my colleagues were there, including Ramsey, who I mentioned earlier. And they set up this pitch, I guess this penalty kick area. And you're taking basically a standard soccer penalty kick, except you have these two targets, no goalie. And you're just trying to hit those two targets, and you're getting points for three things. One is accuracy, so how close you are to the target. Two, for power, so kind of how fast it gets there. And three, for style, which was a little bit more subjective, but how you kind of looked. We'll get into that in a sec. So they had the whole demo here, and we're happy to talk about this more. I'm going to gloss over a bunch of details, was 3-pixel phones. Right? So there's one focused on the camera, one focused on the goal, one on the side, and one on the kicker. So we're going to talk about the kicker value. So what happened here is about 1,400 people went, or 500 people took about 3 kicks each, so 1,500 kicks. We had video uploaded. And then the idea wasn't just to look at the videos, right? That doesn't do me much, but turn it into actionable insights. So again, this is a new thing. This is not a thing, at least in like sort of traditional data science, where you're like, oh, I have videos, what do I do with them? Maybe I watch and I'll record some things and then I'll turn that into data. This video intelligence API with a new feature that I think is going to come out very soon called pose detection, which others have talked about. Neil Johnson of ESPN just did a great presentation about it. But this is the Google version of pose detection. We'll basically take a video and say, not only where was the person in the whole video, but where were all 17 of his limbs. So the point here isn't what the code says. It's that it's an amount of code that basically says, like, tell me where the video is, tell me where you want it to go, and then like and say, please give me pose. And then it turns this video with minimal sort of coding into what you see there, which is a bounding box for the person, and then for 17 joints on the person, where their XY and where the XY is of their shoulders, elbows, all these sorts of things, with a confidence value as well. So you can get some idea of like, hey, this might be very accurate versus a little less so. So this is pretty, when I tried this out, I was like, wow, like I program in Python some, but I'm not an expert here, but without really understanding, I can get the things I want to get out of this. And then we'll go one more step and turn it into insights. So if we take the output from the data across all the kicks, we can then put it back into BigQuery, which we talked about earlier, and then we could do some sort of similarity scoring algorithm to find unique kicker movements. So what I did was, like, I didn't watch all 1,500 videos, but I wanted to see some interesting ones. So I put all the data into BigQuery with the help of my colleagues, of course, and then I sorted by the similarity score, and I found the one that was like kind of more unique, and I went through the top few. So this one came up, and I was like, oh, this is kind of different. So the guy does a little shimmy, comes up, rotates his hip, and does a kick. All the other ones are pretty standard penalty kicks, right? So if I'm interested in finding some interesting, different poses, this type of thing allows me to do it in an automated way. We also track the ball. I'm going to skip over this AutoML vision, and now we have actually a shot chart basically for every kick, and then you can highlight the individual players. So I did want to leave time for questions. So basically want to say Google Cloud makes things, allows you to scale, do things easily, and allows you to do all sorts of things, including a bunch of new things. So with that, I'll leave you with one other video of our colleague Polong doing, this was another one that came up as a very unique kick. And yeah, I'm here. This is where you contact me. Happy to take questions here. And if you want to run queries or get Google Cloud stickers, I'll be outside afterwards.
Hey, hello. I noticed you said it was like 7 billion rows, and then it processed about 600 gigabytes. Was that the entire data set, or was it only processing some of the data?
Yeah, good question. So in theory, I start with the entire data set. BigQuery is like the reason it's fast is all these optimizations. So behind the scenes, it might be taking some of the filters I had, passed them up, and then said, I think it said it processed 600 and the whole thing was 1.6. So I think it ends up passing some of them back and maybe like understanding that it doesn't need to use exactly every single frame. But I wrote it as if it was going to, I didn't write it as to like only take one season or something. So.
And is that also potentially like skipping the columns that aren't relevant?
Yeah, I think that's right.
Yeah. Did you look at the cost of like one of those queries? Or, I mean, I'm sure you're not charged for it, but we might be.
Yeah, no, great question. Yeah, so I think like, yes, obviously it costs money and to run these queries. I think the way that BigQuery pricing works, again, I'm not a salesperson, is that you can buy like a fixed amount, like you can pay up for whatever amount, and then you run whatever each individual one's cost doesn't matter. This one is on the order of, I would say, cents to dollars. So that's a huge query though. Like you wouldn't, if you run it once, you're probably okay. You probably don't want to set some automation to run that every 2 minutes, right? So like that's a different story. But yeah, I think it's, you pay for how much data you process. I think the rates are pretty good. And then there's ways to definitely put in cost controls and things. So.
Is the posed estimation for like objects in addition to just people?
Pose estimation is for people. Object detection, which I skipped over a little bit for the ball, is for like objects like a ball, like it'll tell you where it is, yeah.
But not the well, a ball doesn't have much orientation, but like a robot has poses as well.
Yeah, I haven't, in theory, you could just put something in and it might say, yeah, like the robot has like limbs or whatever, but it's trying to pick up on like what is generally, like using artificial intelligence, what is a person and where would I map them, yeah. Cool. Awesome. Cool, all right. Thank you very much, everyone.